Hey guys, welcome to Monday, April 13th. Hope everybody had a good Easter weekend. You'll be happy to know that I am decided that I'm going to shorten things up a little bit more as I get better and better at this. We're going to go ahead and spend a couple days on each section that we have left in chapter 9. And I think that'll take us through next week, actually. There are 3 sections left, and so we'll probably take 6 days to do it. And I think that'll shorten up the notes and the homework just a little bit more even. So let's get started. Here we go. So today we are going to look at there we go. Finding the solution region, right, to a system of inequalities. Now, as I wrote here, earlier in the chapter, we graphed an inequality in 2 variables. Remember, we kind of graphed it, and we drew the line, and maybe it was solid or dashed, and we shaded one side and we found the solution region, or we found the region that has all of the ordered pairs that are solutions to an inequality. And down here I've put the basic steps that you did to do that. First, you had to determine how to draw the line, generally by using the slope and the y-intercept. Then when you draw the line, you had to determine if it should be solid or dashed. Remember, solid is when you include the or equal to. And then you had to determine which side of the line is the solution region by testing a point to see if it was a solution. And of course, you shade that region. So the only thing we're changing in this section is, instead of a single inequality, we're now going to be solving a system of inequalities, which simply means that we are looking for a region of ordered pairs that are solutions to both, or all, if there's more than 2, inequalities. And we will do this essentially the same way. Graph each inequality separately, as you've done before, but only shade in the region that are shaded by both inequalities. And of course, I wrote here, if you were looking for the region that is shaded by, you would be looking for the region that is shaded by all inequalities if there were more than 2. But for now, we're just going to be doing 2. So let me do a quick example for you. This has one good point to it, and then we'll be done. So if I wanted to graph this system of inequalities, I might first get it into slope-intercept form by subtracting 2x from both sides, giving me 3y equals negative 2x plus 6. And then divide everything by 3. And I get y equals negative 2/3 x plus 2. And I'm ready to graph, right? This is your y-intercept, the 2. So I'm going to put a dot there. I feel like that's totally focused. Well, there we go, maybe. Not sure that's any better. And that's a little better. And the slope of this line is negative 2/3. So from there, I'm going to go down 2, right 3, down 2, right 3, or maybe up to left 3. And I'm ready to draw my first line. Now I notice up here that there is not an or equal to sign, so that's a dashed line. And the side of that line that has the solutions, well, I'm going to test the point 0, 0 like normal. So putting that into the original inequality, I would have 2 times 0 plus 3 times 0 is greater than 6, which would be 0 greater than 6. That is false. So that tells me that the solution, this point 0, 0, is not a solution, and the solutions must be on this side of the line. Now, I'm not actually going to shade that side quite yet. So then I'm going to go to the other equation or inequality, and I'm going to draw its line. So again, the first thing I want to do is get the y by itself. And when I do that, I would get y equals x. So this is a line that has a slope of 1 and a y-intercept of 0, right? You just need to know that the coefficient of the x is 1 and the constant term out here is 0. That's why there is not 1. So to graph this line, I would put a y-intercept at 0 and a slope of up 1, right 1, or down 1, left 1. So that line is going to look like that. Now again, this does not have a or equal to. I wish I had made it have an or equal to. So I'm going to make it a dashed line. And I have to decide which side the answers are on. Now this is a rare case when I cannot test the point 0, 0 because the point 0, 0 is on the line. So I'm going to take my original inequality and I'm going to test the point 1, 0. That is x equals 1, y equals 0. So that would look like this. In the original inequality, I'm putting 1 in for x, and I'm putting 0 in for y, and I get 0 is less than 3. Well, that's true. So this point right here is a solution, and I would be shading below to the right of this line. So when you draw two lines, and they cross here, what you make is 4 different regions, right? Here's region 1, here's region 2, here's region 3, and here's region 4. 4 like slices of pie is what it looks like. And you want to shade in the one that makes both inequalities work. So that would be below this line, but above this line, which gives you this slice of the pie right here. And this is the region of the graph that has the ordered pairs that are solutions to both inequalities. This is your solution region. All right, I think that ought to do it. Good luck. We'll see you tomorrow.